Hello everyone and welcome back to the channel. In this second video about AI agents, we will see how we can allow LLMs to search the web. We will be using Tavily Search, which is a great search tool specifically made to power AI models. It works by first getting the most accurate search results, then ranking them by order of relevance, and finally feeding them back to the LLM. This makes it incredibly useful for multiple agentic workflows including research, data enrichment, and chatbot applications. As we did in our first AI agents tutorial, we will first create a web search tool using Tavily, then use LangGraph to build our web-powered agent. Let's get started. So to create our tool, we will use the LangChain integration for Tavily Search, so start by installing the LangChain Tavily package. Next, we load our secret YAML file, in which we have stored our Tavily API key. To get a free API key, you just need to go to the website, scroll down to the plan section, and choose the free plan. This plan gets you 1,000 search credits per month, without requiring a credit card. Click on Get Started, log in with either your Google account or GitHub account, and you'll land on this main page. Here you can get your free API key by clicking Copy, and you can quickly check the status of your credit consumption. Moving back to the code, we use the Tavily Search class from the LangChain Tavily package to instantiate our search tool. Here we set max results to 5 and topic to general, but there are many more arguments we could manipulate. Let's take a look at the documentation. You have the topic, which we set to general, but it can also be set to news, the max results, which we set to 5, and the time range to filter results, for example, only from the last week or the last day. You also have the option to include an LLM-generated answer to your query, based on the search results, as well as an option to include image results. Finally, you can either include or exclude specific domains in the search, for example, to only get Wikipedia or Yahoo Finance search results. Now to use this search tool in our code, we can simply can the invoke method, as the Tavily Search class already implements the LangChain runnable interface. Let's ask it, for example, how the Tesla stock is doing. We get a JSON output containing our list of results. Each result contains a title, a URL, the content, and a relevant score which is used to rank the results. Now all of these search results can be directly fed to an LLM to help it answer a question. And just like we did in our sourced RAG tutorial, we can easily instruct the LLM to also provide the source URL in the final answer. Let's now build our web-powered AI agent. Just like we did in our previous tutorial, we will build it using the LangGraph framework. If you're not comfortable with the LangGraph terminology of states, nodes, and edges, make sure you watch our previous tutorial first. So as usual, we first define our state containing only the messages, and use it to initialize our state graph. We then instantiate our LLM, build our LLM node with a call function to invoke it on the state's messages, and initialize it with our LLM after binding the search tool to it. We also build a tool node from our search tool, add both nodes to the graph, and finally, add the edges. A first edge from the start to the LLM node, a conditional one from the LLM node to either the tool node or the end, and a last one from the tool node back to the LLM node. Finally, we compile our state graph to obtain our agent and display its graph structure to make sure everything was set correctly. We go from start to LLM, we have this feedback loop between tool and LLM, and we go to end once the LLM reaches a final answer. Let's now see what our web-powered agent can do. So for the sake of comparison, let's first ask our raw LLM this simple question: what is Anthropic's MCP? As you can see, the raw LLM couldn't answer this simple question. This is normal because it requires information that didn't exist at the time this model was trained. The LLM we're using is Claude Sonnet 3.5, specifically the version from June 20, 2024. Since Anthropic only announced the open sourcing of their MCP protocol in late November 2024, this model couldn't have known about it. This is where our web-powered agent makes the difference. Let's try asking our agent the same question: what is Anthropic's MCP, and see how it will answer it. And just like we saw in our last video, it takes our human message which contains the question, and replies with an AI message containing a tool call to our search tool, along with a search query. The tool responds with a tool message containing the search results, and the LLM replies with a final AI message containing a full detailed answer to our question. It includes the definition, The purpose: a funny but very accurate analogy comparing MCP to USB-C for AI apps, as well as applications, adoption, implementation, availability, and resources. The bottom line is that MCP standardizes the way AI models interact with data sources and tools, which will be the subject of a future video. And that's it for today's tutorial. If you appreciate the content, make sure you like and subscribe to the channel. See you in the next one. Bye-bye.